All right, this video is going to show how to measure earthquakes. Again, we want to take these qualities that we've been talking about with the earthquakes, and we want to assign a number to them. We want to quantify them. So how do scientists go about quantifying them or measuring them? First thing, we have an instrument that we use, which is called a seismograph. This here is a very, very rudimentary type of seismograph. Nowadays, you do get digital ones and using computers and stuff like that. But at the very beginning, this is what our seismograph looked like. Basically, we would set it on a surface, and we would assume that surface is going to move. So let's put it next to a fault line where we're going to get a lot of movement. You're going to get a horizontal or left to right movement, and in doing so, this little stand here is attached to it, and we have a string with a weight on it. And as I move this is going to move like a pendulum. At the bottom of that weight, we do have a little pencil, marker of some sort, and we have a drum roll of paper. And as it moves, this pendulum is going to move, and it's going to make marks on the paper. The more this moves, the longer those marks are going to be, and you're going to be able to detect whether the Earth is moving and how much. So once we have that seismograph, what do we do with that information? Well, we're going to record magnitude. Magnitude is a big fancy word for strength. How much strength did that earthquake have? So we're going to measure the earthquake strength based on these seismic waves that it produces, so these S&P waves that come up. We're going to measure how much they shook the earth where that seismograph is, and we're going to assign a magnitude to it. There are 3 scales that have been used in the past. Currently we mostly just use the moment magnitude scale, but we do have the MERCALLI scale and we do have the Richter scale as well. So let's take a look at each of those. Let's start with the most rudimentary of scales is the MERCALLI scale. This was used years ago, in the early 20th century, so early 1900s. And basically it was to use a rating scale to rate earthquakes based on intensity. So intensity is going to be measured the strength of the ground motion in certain places. Depending on where you put that seismograph, you're going to get different readings on it because the Earth is going to shake differently from each individual point. The MERCALLI scale is going to rely on a 12-point scale, and it is going to be measured based on how earthquakes affect people, buildings, and the land surface. So not necessarily all just on strength, but how it affects the location around it. And again, different locations are going to give you different measurements, so you might have different ratings on your scale from different places. Here's a quick look at your MERCALLI scale. As you can see, Roman numeral 1 up here is only going to be something that's detected by sensitive instruments, and you probably won't feel it all the way down to 12 down here, where you're going to get a lot of damage and thrown objects and things like that. Next scale is our Richter scale. This is rating the size of seismic waves, so not necessarily the intensity of the damage it caused, but the actual size of the waves. We started using this around the 1930s, and this was a good way for small nearby earthquakes to be measured. So I'm good at measuring the magnitude of small earthquakes and making sure they're at least they're nearby to my seismograph. If they're further away, I'm going to get issues, and if they get too big, it kind of gets vague as we go down. So here's a look at our Richter scale. This is a 10-point scale, 0 being unnoticed and pretty much uneventful, and nothing's happening, so we do include it. All the way up to 10, which is going to make a huge impact on the world. The thing is that this actually goes up exponentially. So as you get to the higher ones, you get less of an accurate reading because of it. So the difference between a 9 and a 10 is pretty much the same difference between a 1 and a 9. So you do get kind of a vague thing up top. But for small nearby earthquakes, it works really well. The scale we use now is the moment magnitude scale. And this is going to measure the total energy released by the earthquake. It's going to be good for all sizes of earthquakes, near or far, and it's kind of just a more standardized scale. Just for a point of reference, things that are rated as a 5.0 or below are going to be called small and cause little damage, while anything that is a 5.0 and above we're going to refer to as a pretty hefty size earthquake with great destruction. So I'm going to move my head, actually it probably won't block anything, I'll move my head up here and get you a look at this. As you do get down, you get your descriptions here and you get your different point scales here. And it is a range, so they will get things that are like an 8.3 or something. Just a little more detailed than the other ones. And again, this is based off of the seismic waves.